All right, guys, so this is the third and final video of the notes for the Chapter 7 midterm. I'm going to remove this so I can write here. Okay, and we're going to talk about properties of trapezoid and kites, which is section 7.5. Okay, so we're going to do trapezoid first. So by definition, a trapezoid is a quadrilateral with only one pair of opposite parallel sides. Okay, so if I draw that out, this is what that looks like. Okay, so we have a trapezoid. This side and this side are parallel. Okay, the other two sides are not. This side and this side are not. Okay, now an isosceles trapezoid has an additional property that the legs are congruent. Remember, in a trapezoid, we have two bases, and the bases are the parallel sides, and then we have two legs, and the legs are the non-parallel sides. Okay, in an isosceles trapezoid, it's simply a trapezoid with congruent legs. Okay, now we have some properties, and this is just pertains to an isosceles trapezoid, not just any trapezoid. Okay, and the first one is that angles along the same base are congruent, meaning that these two angles are congruent. Okay, and then these two angles are congruent. Okay, another property of an isosceles trapezoid is that the diagonals are congruent. So if I draw the diagonals, this here is congruent to this. All right, so let's look at some examples here. Okay, in example 1, we have a trapezoid, and we know it's a trapezoid because these two sides are parallel, these two sides are not. Okay, so we have a right angle here. Okay, now we don't know that the base angles are congruent because it doesn't look like this is an isosceles trapezoid. Okay, so if I think about these two sides being parallel, okay, and then if I draw this transversal here, okay, what we've learned before is that this angle and this angle are consecutive interior angles. That was back in chapter 3, and that when lines are parallel, consecutive interior angles are supplementary. Okay, well, if you notice, if we take these two angles, okay, that would be equivalent to these two angles. So I can say 60 plus angle 1 is equal to 180. Minus 60 on both sides, I get angle 1 is 120 degrees. So angle 1 is 120 degrees. Okay, 120 degrees. Okay, now I can look at this as the same way. Okay, so these two angles would also be consecutive interior. Okay, I have these two parallel sides, and here's the transversal. Okay, we're talking about this angle and this angle here. Okay, so they would also be supplementary. This one's 90, so I could say 90 plus angle 2 is equal to 180. Minus 90 on both sides, I get angle 2 is equal to 90. So this is 90. Okay, now if I look at B, okay, B, I know we have a trapezoid because these two sides are parallel, but notice these two sides are congruent, meaning that this is an isosceles trapezoid. Okay, and in an isosceles trapezoid, I know angles along the same base are congruent, so these are going to be congruent, and these are going to be congruent. Okay, so immediately I know angle J is also 94 degrees. Okay, now to find one of these blue angles, okay, I do the same thing as I did in A over here. Okay, I know these two angles are consecutive interior and they have to be supplementary. So I can say 94 plus angle K has to equal 180 minus 94 on both sides. Okay, and if I put that into my calculator, angle K then has to be 86 degrees, so 86 degrees. Okay, and if angle K is 86 degrees, angle L is congruent to that, so it is also 86 degrees. All right, so we also talked a lot about the trapezoid mid-segment theorem. Okay, a lot of times you'll see one of these on the ACT or something. And we can find the length of the mid-segment because it is always the average of the two bases. Okay, so the mid-segment is, okay, it's parallel to each of the bases first. Okay, meaning that this is the mid-segment, guys. It's going to be parallel to the two bases. Okay, and remember the mid-segment is found by finding the midpoint of AD and the midpoint of BC and then connecting those two. Okay, the length of the diagonal is, okay, it'll be the average length of the two bases. Okay, so in this case here, my two bases are 20 and 12. Okay, let's just call this X. Okay, and to find the average of two numbers, you simply add them up and divide by how many? In this case, there's 2. Okay, so this is 32 over 2, which is 16. Okay, so this here is 16. All right, so now we are on to a kite definition. Okay, this one's kind of long, so you might want to write it a little small. So a kite definition is a quadrilateral, and I'm going to abbreviate, okay, with two pairs of consecutive congruent sides, but we have to put in here opposite sides are not congruent. Okay, and we have to write opposite sides are not congruent because if we allow them to be congruent, a kite then could be a parallelogram, and a kite is not a parallelogram. Okay, so if you look down here, this kite, okay, this side and this side are congruent. This side and this side are congruent, okay, but opposite sides are not congruent. Okay, so that's what a kite is. In a kite, we know the diagonals are perpendicular to each other, okay, meaning that they cross at a 90-degree angle. That's something you should know. Okay, and another thing about the kite is that one of the diagonals, when we draw it, it cuts the kite into two congruent triangles. Okay, so if we look at this kite right here, if we were to draw this diagonal right here, okay, and look at this as two congruent triangles, we know this side and this side are congruent. This side and this side are congruent. By the reflexive property, this side is congruent to itself. Okay, so the left triangle and the right triangle would be congruent by side, side, side. Okay, and that helps us kind of dive into kites and get a lot of, I guess, pieces of it. Okay, so if I look at this kite, okay, I want to find the measure of angle R and angle P. Okay, well now because these two triangles are congruent, I know that these two angles have to also be congruent. Okay, I'm going to erase this so I can read some things. Okay, these two angles are congruent. Okay, well, a kite, guys, is just a quadrilateral. So I know all four of these angles have to add to 360. So I can do 105 plus x plus 55 plus x is equal to 360. Okay, now 160 plus 2x is equal to 360. Minus 160, minus 160, I get 2x is equal to 200, which means that x has to equal 100, not 110. Okay, so x is equal to 100, which means angle R is 100 degrees. Angle P is also 100 degrees.